Hey. So I'm handing out honorary doctorates. Anyone who wants one, please just see me later. Uh, so as you see, the New Oregon Alliance has been really involved in helping to partner with great organizations like NASA, like the National Science Foundation. There's a lot of other partners in the audience today and tomorrow. We focus on accelerating your technology. So that's why this whole network is together. That's why the whole road mapping initiative has come together. That's where we're trying to go with the Vascular Tissue Challenge, with our other prize programs that are out there, with future prizes that we bring together. And a large part of what we do is, even in this summit, is to bring people together to really look at what's next. So even as people start advancing on the Vascular Tissue Challenge, well, what happens next? What do we do with that? What are the other challenges that are out there that we also might be able to try to accelerate? So those are some of the things that we look at as the New Oregon Alliance. One of the other prize programs that's out there that's tied to the Vascular Tissue Challenge is the CASIS Innovation in Space Award. So, CASIS does a award for researchers who can advance their vascular tissue research to actually take that into space. It's a really exciting opportunity where researchers can actually put an experiment up on the ISS through support that CASIS can provide to you. So up next for our speakers tonight is Dr. Michael Roberts, and I believe you do have a degree. I think I'm right on that. So Michael Roberts is the Deputy Chief Scientist of CASIS. He's been involved from the beginning of the Vascular Tissue Challenge and the Innovations in Space Award. CASIS does amazing work to get research on the ISS. So with that, I'm going to hand it over to Dr. Roberts to tell us more about how CASIS is involved in this and what kind of opportunities and research has been done with the National Lab.
Yeah, so this is why I'm here. We don't own the International Space Station. You own the International Space Station National Laboratory. So what we wanted to share with you tonight and over the next couple of days as we talk is to view the microgravity environment as an enabling technology, as a tool that you have available to you as researchers, as innovators, to explore the boundaries of cell experience and the experience of cells in forming tissues and eventually organs. So the solution to all of your problems at the bench every day are not going to be found in space. There are a lot of difficulties in translating the way we act here on Earth to a microgravity environment. And NASA has been working on solutions to those problems at an organismal level for a very long time, understanding ways that we can extend our presence into space so that we can work and continue to operate in the space environment for long periods of time much farther from Earth. In this year of 2018, I think most of you are probably aware, but the high school graduating class of 2018 will have never lived in a world where there were not a crew of space folks working in the space environment 24 hours a day, 7 days a week. So we live in a fast changing environment, right? And in thinking about the ways you approach your daily science and technology development needs, we at CASIS are engaged in helping you to think about taking your research into the space environment where it benefits what you're seeking to do. So in doing that, we've become invested in this challenge as a way to explore new ways to use that microgravity environment to address a very important problem here on Earth. And that, in its heart, is what the essence of the ISS National Lab is designed to do. The International Space Station National Laboratory is designed to enable access to space to address questions that are of value and importance here on Earth. So there are a variety of challenges that are being faced in addressing the organ shortage that have some impact and some value in that microgravity environment. Not all of them. So as with any tool, a tool that's misused has no value to you. But a tool that is appropriately used can help you accelerate and get to your end goal over time. So tomorrow in the microgravity enabling breakout session, we're going to be talking about ways that the International Space Station National Laboratory has directly engaged in partnerships with the National Science Foundation, with the National Institutes of Health, and with NASA to enable access and funding opportunities for researchers to take their science into that realm outside of Earth. Just wanted to spend a few slides to get people thinking about what microgravity and what the ISS National Lab has to offer that may be of value to you. So everything that you've learned here on Earth as you've grown up from an infant is that if you drop something, it goes down, right? If you take a fizzy bottle of soda and you shake it up, right, it explodes. The lighter gas comes out of the top and the heavier stuff settles down to the bottom. All of that's lost in a microgravity environment. And that change in the fundamental physical principles has direct impacts upon the biology of systems. And those effects that directly impact the biology of the system are challenges that NASA has to address in extending the human presence into space. So we have representatives in the audience tonight from Human Research Program who focus on understanding what those challenges are to the whole body and ways to address and develop countermeasures that can make humans work effectively in that environment for long periods of time, farther and farther from Earth. But from a researcher's viewpoint, those challenges to the organism represent opportunities for investigation. In some cases, those challenges to the organisms represent accelerated models of disease that are present here on Earth. So there are opportunities then to look at cell aggregation and signaling. So even at an individual cellular level, there are opportunities to understand the impacts of microgravity upon that cell. And then from that, extrapolate ways that you can cue the cells to form the types of tissues and organs that are of most interest for you. There are also opportunities to address those studies from the individual cell level, again, to whole organisms. And many of you, I'm sure, are aware of the press of the recent NASA-funded experiment to look at twins, one who was in the International Space Station for almost a year, and his twin brother who operated here on ground, both astronauts, but had different periods of exposure to that space environment. And from that research, there are already very exciting findings that are related to the level of gene expression, the level of telomere expression, the level of control at a cellular level that occurs upon extended exposure to that microgravity environment. There are also opportunities for fundamental technology discovery, looking at ways to increase the number of drug products and drug targets that are at the front end of the pipeline, and ways to understand the efficacy of those drugs at an individual cellular level or an organism. And most importantly, from my perspective as a former microbiologist, looking at the interaction of microbes with all of those systems. And very simply, it comes down to this. At a biological level, cells are responding to that absence of gravity in that free fall environment, and that has very direct impacts upon the way they associate with their environment. So all of their environmental cues are changed in that environment of microgravity. And that directly impacts the ways that the cells can associate and form higher levels of structure from spheroids all the way up to whole organs. So what we're seeking to do at CASIS is to enable pathways of research that enable investigators to utilize the International Space Station National Laboratory. We've done this primarily through partnerships with other government agencies, the NIH and NSF that I mentioned. We've also funded some grants on our own, some small seed funding grants, starting at simple measures to understand how stem cells proliferate in the microgravity environment, helping to develop technologies that can improve the types of research that can support the proliferation of stem cells in that environment, and slowly growing that up to increase ever more complex experiments and ever higher levels of physical organization of the cells and tissues. So we've had great success through a variety of programs, some self-funded, as I mentioned, looking at stem cell research. leading up to more recent partnerships with the National Center for Advancing Translational Science at NIH, which has now funded 2 rounds of Tissue on Chips, Space Chips program for International Space Station National Laboratory. And opportunity with the National Science Foundation to include in that type of assay queries to understand the ways that the biology and the physical dynamics of the tissue growth systems interact in that microgravity environment to further enable research into the future. So what's next? I don't have the answer for that, but I think the answer lies somewhere out there in the audience tonight. So as you're thinking in each of your breakout sessions over the next day about areas of challenges that exist in your particular area of research for addressing the organ engineering shortage, technologies that you use in your laboratory, take a few minutes to think about taking those challenges or those technologies into the microgravity environment, and think if there are ways that that environment may actually accelerate your pace of discovery and research. I'll be here. We have other representatives of CASIS in the audience. Jana Sudemeyer is here. She represents Space Tango. There's representatives from TechShot in the audience as well. These are companies that we call implementation partners that help enable translating your science into the space realm. So it's a little bit more difficult to do an experiment in the space environment. It's a little bit more difficult getting your research to the International Space Station National Laboratory than it is getting your research into a bioreactor down the hall, but it's worth it. So give it a try.